Hey everyone, welcome back to Dev Parkour. In this video, I'm going to show how to build a routing engine, not necessarily from scratch, but built on top of the Pails foundation. So it had a very rudimentary routing engine built in, but this will basically show how to take a URL and some sort of routing configuration and turn it into something reasonable. So in Pails, there's actually this function request for URI, which very simply takes a URI and converts it to a request object. And what that request object looks like is controller name, an action, the raw parts of the URL, options, and then something called area, which we'll gloss over most of this. But the important part is controller and action. And basically what this means is it is the result of that request for URI function should return basically an indication of what method on what class we're actually going to run to handle this request. Now that in itself, that's great. We need some context in order for that to actually have meaning. So if we go over to application, which is kind of the thing that runs it all, there's actually a register router function, which all it does is takes a thing and sticks it in this routers array. Now, if we go back to request for URI, you can see on the right hand side, that's where this .routers is referenced again. So basically, request for URI will iterate through any registered routers and basically just call it. It's a callable. It's nothing more than that. It's just a callable. So it could be a function. It could be an anonymous function. It could be a method on a class. And we're going to take advantage of that last one, make it a method on a class, to actually add a bit of routing logic to Pails. Back in the day when I originally built this, I intended that everything would be, your routing table would just be an array of controller and method, or sorry, URL to controller and method. And that's it. That would handle everything. That was a little short-sighted, and when I started building a content management system on top of it, I realized that I needed a little bit more. I needed to be able to just take an arbitrary URL and map that to, well, realistically something else. And that's when this request object came about. Because for a content management system, every single route, every single URL is going to get mapped to the same controller and to the same action on that controller. Something like, content controller and the action being show post, or, something like that. And then what would change is the post ID or something like that. And that's all encapsulated in this request object. So remember, options, that's where that ID would come up. And that actually worked really well. However, at some point in time, I realized that this routing table concept was, as I said, a little bit short-sighted. The idea of how a content management system worked was cool, but not every application that I wanted to write would follow that CMS pattern. So I ended up actually at one point in time, let me bump that up for you. I started on some project. I don't even know what this project was intended to do, but I started with Pails and I decided, you know what? I want to use a different routing strategy. I basically wanted something more akin to Express, or more akin to, well, Express and things like it. I'd actually built something kind of like this in C# for the job I was at the time. Worked really well. Really easy to understand, especially if you were coming from, well, basically any web background. So I wanted to add that onto Pails. And this is kind of the interface that I came up with. So again, this is just a project that I think this file and the router file that we'll see in a minute is about as far as I got on this project. But that doesn't even matter. This is the important part. Basically, I have a path called sign up, and apparently I have two paths called sign up. One's get and one's post. And here's the class, here's the action. It's basically fairly straightforward. You can see here app register router. There's that register router function. And in PHP, this array is actually a callable. PHP does some magic to determine that what you're saying here is that you want to be able to call the resolve method on the $router object. So in today's video, in the rest of today's video, I want to take this and actually bring it into mainline Pails because I really want it to be available everywhere. I don't want it to be part of a plugin, and I don't want to have to do a bunch of wacky stuff just to get this experience. And then maybe later on down the road, I'll actually deprecate and remove the old routing table. That would be pretty cool. So this is not the part that we're actually going to pull into Pails, because this is just how you use it. What we are going to pull into Pails is actually, let me open this in a new tab. We're going to go to router.php. And you can see it's a fairly simple file. Basically, each of these get, post, put, patch, delete methods are just a thin wrapper on add route. And what add route does is it creates a key out of the method and the URL pattern, and then stores it in an internal routes associative array. And it doesn't allow you to register duplicate patterns. So method plus pattern has to be unique. Obviously, that makes sense, because you wouldn't want ambiguity. You wouldn't want multiple functions to get registered as handlers for the same URL. That wouldn't really make any sense. But then all the magic happens in the resolve function, which I think was what was registered as the router. Yeah, router resolve. That's the actual router function. So basically, we get a URI, we get a method. That's the contract, the expected API for this resolve function. Iterate through routes. Iterate through the key value pairs. And again, we construct the key from the method and the URI that's coming in. And then for right now, it's actually very simplistic. The patterns don't support regular expressions or anything like that. That's something we might want to add later on. So basically, we construct a controller name. Controller name, controller, we get all this information, action, all that good stuff. And what is value? Oh, value is value, right? Okay, so that gets us the controller. This gets us the action. And then, raw parts. It gets us the raw URL segments. Options is, it looks like all the values in all the array values from this value method. I'm not really sure what it's doing there, but we'll start with this and see what happens. And then we just return that, right? So if we have a matching key, then we return this constructed request object. Otherwise, we return false, which also follows the contract from what request for URI expects. If it gets something back, it expects it to be a valid request object. Otherwise, something falsy. Otherwise, it continues on to the next router. So let's just take this whole file. Let's just copy this and go over to pails, new file, router.php. Now, one thing I do want to change is if we go back to here where we're using the router, there's this extra app register router call. I would like to be able to just pass in application to router and have it automatically register itself. So let's do that. So there's actually no constructor here. So let's create one. All right, so there we go. We have our router. Now, what I want to do is fix this. So I want to do something like is match for key so that we can this is the real URL, but key could have wildcards in it, it could have a star, something like that. Basically whatever we want it to have, we get to define it here. So let's create a member function called is match for, and let's actually make this static. We'll stick it down here. Public static function is match for, and here's where we're going to compare the pattern to the actual value. Now, this would do regular expression. So we could do something like, auth.splat goes to, it would match something like auth login, auth log out, and so on and so forth. But that's really not what we want. Typically, you have things like that. You have things like that. You have things like something like that, which should probably also match that sort of thing. Then you might also want something like that, where you have, recursively, like anything, multiple path segments. So this would typically indicate a single path segment. This would typically indicate multiple path segments. So each one of these introduces a little bit of complexity, but I'm going to pause for a second while I think about how I'm actually going to implement that. All right. So I thought about this for a little bit, and I came to a realization. So while this is technically a bit of a parsing problem, we do have something like this, and we need to figure out how it corresponds to an input. We don't have to worry necessarily about going character by character, because A, we can make that decision, but B, what we really care about is if individual path segments correspond to matching path segments. So for instance, here we have a string auth, and that needs to match verbatim the corresponding path segment. This is a wildcard. It can match anything, but it only eats up one path segment. And then we have nothing left. We need to make sure that we also have nothing left in the paths that we're comparing it to. However, it's not just a matter of what we do with each index, with each path segment, and does it match, does it not match? In some cases, we might not want to, we might want to do something with that path segment. So in this case, we want to save that path segment. So if this is logged in, we want to save that as action somewhere. Let's just say an associative array. So for sake of argument, let's call it ops. Right? So now let's actually write this loop. I think we'll want to loop over the segments in the pattern. We'll start there, and if we fail, then we'll change. So let's start with pattern segments, and realistically, we should let's do TDD on this. Why not? That sounds like a good idea. This is something that is really very easy to test. There we go. All right, so now we have a folder called test. Let's create a new file in there called router test.php. And it's been a while since I've used PHP test, so let's see what we have to do. Okay, so extends test case. Okay, that's fine. And each public function that starts with test is a test. So let's do that. Looks like the convention is to call it tests. Okay, so let's actually rename this. Rename tests. Okay, and then router test. Yeah, test. Okay. Let's create our first test. First, we have to have this use test case, and then final class. It's final so that it can't be overridden, because this is a test class. It doesn't make sense to inherit from a test class. So we'll call this router test. Router test. Extends test case. Let's start with something simple. So we're actually testing specifically this is match for function. So we'll also want to require once the class under test. So we'll use something similar to what we have here, right? Let's require once that. And this is router.php is what we want. And then we'll be calling router. What's the name of the function? Is match for. Is match for. And let's start with something simple. This is a path. This is a path. Right. And we'll want to assert something, right? So this assert equals, let's just do this assert true. I think that's a thing. We'll find out in a minute, won't we? Let's test 1, assertion 0, errors 1. Class router not found. That is interesting. I mean, we've got syntax errors, so that could be the issue. No, it's not, because we need use pails router. Obviously, we could either do use pails router, or we could just do that down here, but I'll do the use up here, make it a little cleaner. Let's see. Yeah, now we get syntax errors galore. So let's actually do, let's just comment that out. This should be a bool, so let's give ourselves type hinting. Let's say if we get to the end and we still haven't found a match, it's just return false. So now we should get a failing test. Except we get a passing test. So why is that? Oh, because that. Yeah, obviously. Okay, so now let's do add a trailing slash. And I'm just going to copy this whole thing. And then is match for, we have a pattern and we have an actual. So let's say the actual has a trailing slash. Failures, yay! Okay, so now we have our first failing test. So one thing we could do is just see if there's a slash at the end of one or the other, remove all trailing slashes, and then compare, but that doesn't really get us anywhere long term. We really want to start doing a segment by segment comparison. So let's do pattern segments equals explode on slashes. And so this is pattern, so we'll actually do pattern. Then we'll want to do actual segments and do the same thing. Actual. And now what we should do is for loop. Well, let's actually get to that as another test. So If pattern segments does not equal actual segments, return false. Let's start with that. We still have a failure. Now, why do we have a failure? The reason is because we really want to eliminate empty pieces. So let's do an array filter. There we go. And we'll do the same thing here as well. Right, that looked good. Now I actually want to separate this out into its own function just for reusability. Since we copied and pasted here, I really want this in its own function. So let's do split segments. This is pattern. And I'm actually going to put true there. You'll see why in a minute. Let's see, public static function split segments. Let's really not match case. Let's this will be URI. This will be omit empty segments, and by default that will be false. What we'll do is we'll do segments. We'll do that. What we'll actually do is omit empty segments. If it's true, then we'll do that. Otherwise, we don't do that, and it's just segments. Actually, let's do this a little bit different way. If omit empty segments equals. The reason I changed that is because I saw a little performance issue. With the ternary, we would be running this array filter anytime we call this function, whether or not we actually use the result when we omit empty segments. So this will gain us a little bit of performance, since we will be running this multiple times on every single URL, every single request. So let's fix this up. Self split segments. This is actual. All right, now let's see if that passes. Errors 1, undefined variable pattern. Sure enough, there we go. Okay, this is why we do this. Undefined variable segment. Yep. Undefined offset 0. Well, let's write some more unit tests to make sure that we didn't screw anything up. Let's start with this as our URL, and what we'll do is expected equals that. And notice, well, we'll do that. So we only get 4 segments. And then actual would be router, what is it called? Split segments. We'll do that. And true. And we assert equal, I think actual comes first, if I'm not mistaken. Assert equals. Array keys are preserved. Let's see. There we go. now exact route with trailing slash is still failing, but at least test segment splits is correct. I think if we set this to true, it should pass. Yeah, there we go. Now let's do something a little bit different. Let's do test does not match exact route with missing pieces. So what we're going to do is we're going to start off with that. So where the pattern is shorter, that's not true. This should be that, right? That should fail, right? So let's make that true. So this is the pattern is short. So if we get to the end of the pattern and we have also gotten to the end of the input. So in order to do that, we actually need to bring I out of to a larger scope and return I equals count of this will be actual segments. There we go. Okay, so now let's test the reverse. This is a path and the input is short, right? Obviously should not match. Yep. Undefined offset 2. That's what I expected. So here we need to say if I is greater than or equal to count of actual segments, return false. There we go. Another way to do this would be if is set actual segments I. I kind of like that better. If not is set. Let's try that again. There we go. Yeah, I like that. Okay. So now that took care of that took care of the easy case, right? So we've taken care of that. We need to take care of these other ones. All right, so let's start with this guy. All right, we have our failing test. Now let's make it pass. Okay. So if it's a wildcard, we just continue, right? Still failing. I must have not saved it because now it's working. Okay, that's always good. Always remember to save your files. There we go. Okay, that did do what I expected it to. Cool. But that should not pass. Or well, it should. That test should pass, but that should not match. Yeah, cool. Also, Also, we should be able to put that in the middle and have it still pass. Success. Okay, so with that, we have taken care of that one. So now this one's a little bit different. This one, we will still be playing with this branch of the if, but instead of just continuing, we will, we actually might just create another one up here. And basically, if it starts and ends with curly braces, then everything in between is going to be a name in this ops array, a key in the ops array, and the actual segment is going to be the value. So let's write a test for that. So public function test. Something like that, right? And at this point, it should fail. It just, yeah. So what we need to do is, and there's actually a reason why I'm going to do this. And it passes. However, what we want to do is actually everything in between the curly braces, so in this case ID, we want to map to 42. So let's do that. Let's say key equals substring, and it's going to be pattern segments I 1, no, pattern segments from 1 to -1, and then value is going to be actual segments. It's going to be that, and then ops equals, no, ops key equals value, right? Now we need some way to get this back out. So my thought would be we do something like this: ops equals empty array, and then over here we can pass in ops, and we'll actually define that as empty array, and then we can this assert equals count of ops is 1, and this dot assert equals ops ID is 42, right? And that is successful. With that, I think we've knocked out another one of these cases here. Let's make sure that this, well, this is actually not valid, but let's make sure that a path like that works, right? So something like this ID, let's do something like that. Obviously this is going to be 2, and this would be action post. Boom. Okay, so we're doing well. Let's cross that one off the list. Now let's do this guy. this only makes sense at the end. So I think we should do a couple different things. But we'll just do one for now. So public it's as simple as that. That's all we want. Yep. Failures. So let's if pattern segments I equals that guy, just do that. Done. Now let's check one more thing. Should that be valid? Let's actually test that. Okay. So it's not valid. Why is it not valid? Well, is that a bad thing that it's not valid? I think that's actually right. My personal opinion. I think that is perfectly valid. But it's really important to have that test here because we specifically say that having the double wildcard at the end means that you have to have something afterward. Now, we will potentially, at some point, I might go back and add something like that, make path pieces optional. Another case where it might make sense is something like that. So making the last piece of a path pattern be optional. That seems like a reasonable course of action. But for now, everything is required. Everything. So I'm going to commit this and push it and make it available and start using it in Glassminnow probably. Thanks for watching. I hope you enjoyed the video. If you did, go ahead and hit that thumbs up button. Click subscribe and click that notification bell so you'll be notified when other videos come out. I really appreciate that. This channel wouldn't be here if it weren't for all of you wonderful people out there. And if you have any comments, questions, topics for future videos, go ahead and leave a comment down in the comment section below. I really enjoy reading those and responding to everybody who writes. Thanks for watching, and I'll see you in the next one.